every failure in a pilot is a learning moment. Every failure in production is a business event.
People who are running shop floor operations, they have very low tolerance for something which is not proven, which cannot be trusted.
The biggest myth is AI is intelligent because it has to be trained, guzzling a lot of data, a lot of information. Then only it can become intelligent. The human part cannot be outsourced. Rest, I think the way Dilip said, it will be slowly taken over. But then this is the part will be differentiated between a robot and a human.
You are in the right place at the right time. If you are one of those people really interested in figuring out India's steel story and how it's being shaped by people, technologies, and really bold decisions on ground. Welcome to the Steel of India podcast. That's why I said you're in the right place at the right time, because this is where we treat you to perspectives and what's changing on ground and what the future for the industry really looks like. But in this particular episode of season 2, and we call it Intelligent by Design, we're going to explore AI, robotics, automation, and how these are actually part of how enterprises think and decide across a range of functions, whether it's the plant, whether it's logistics, or different functions within the organization. But there is one thing that I think we all need to remember, and it's this. Heavy industry typically designs for resilience. It designs for safety and uptime. It's not entirely comfortable to experiment with reality. So then the question is, how does one, build intelligence into such a world without making it a bit fragile? Luckily for us, we have the answer to that particular question and about 10, 15 others, thanks to our guests who have joined us on the show. We have today from the Jindal Steel side, Indradyumna Datta, who is the CDO of Jindal Steel. He drives a digital transformation for the entire value chain of mining and steel. And he's also someone who has over 2 decades of experience in IT, in digital technologies, in IT and OT integration. And he's been leading quite a number of initiatives that are reshaping the way Jindal Steel functions on a near daily basis. So his inputs are going to be invaluable to our conversation today. We also have with us Dilip Sawhney, who's here. He is Managing Director of Rockwell Automation India, and he brings with him about over 25 years of experience in industrial automation and technology. And he's also chair of CII's Smart Manufacturing Council, which puts him in quite the vantage position to see how India's industrial landscape has been evolving. We're going to look to him for plenty of direction on that front. And of course, no conversation can be complete without an understanding of connectivity, of data, of security. So that lens is going to be brought to our conversation by Daisy Chittilapilly. She is the president of Cisco India and South Asia. And she has over 30 years of experience in technology, and 2 decades of those she spent in leadership positions at Cisco. She's also part of the executive council at NASSCOM, so you're in her safe hands. Richness of perspective is something that we're going to guarantee for sure on the show. Welcome to all of our speakers.
Thank you.
Glad to be here.
And Indro, I'm going to start with you. I hope I can call you Indro.
Absolutely.
This buzz, right? No conversation really today begins without mention of AI, whether it's a living room conversation or it's a conversation like this one, a podcast. A lot of buzz around AI and manufacturing specifically. But what have you observed, Indro, to be a sort of a misconception when it comes to people's understanding of what it takes to build intelligence into operations? What's that common mistake people make?
So before I go to the mistake part of it, I think it is imperative to understand what is the meaning of AI in manufacturing, right? So AI in manufacturing is building the intelligence, that can be distributed to the entire value chain of any of the process, whether it is steel making. So when we talk about the core operations or sales and marketing, logistics, supply chain, you can have intelligence in the individual areas. And then when you gather them up and make a super intelligence, and you mimic the human intelligence, but you are going to get out of the best operators, the best decisions ever taken with the historical data, then you actually arrive at the super intelligence. So that is actually AI in manufacturing. Now, where it is used to take a better decision. Now, better decision can be like, I can make something autonomous. I can make a decision where human is in loop. I can make something more connected, because the information will flow from one part of the business to the other part of the business. But I think what it is not, and your original question is about that, is that just deployment of a system, a technology, or a tool. It is not about just deployment of a, let's say, a LLM-based a chatbot, the large language model-based chatbot, which is like the craze of the time at present. So it is not, because until and unless it is giving some value, it is giving edge to my operations team, my CXOs to deliver a decision, and many of the cases autonomous way. I think that's where we are actually heading, and it is not only about deployment of a technology or a solution.
Absolutely. Dilip, you're on the subject of, gaps, and there's this other, around AI, there's this other buzz. There are AI models that demo really very well. But then there are AI interventions that actually are trusted by operators on the real shop floor. What's the distinction between the two, and how can one tell the two apart?
So, Sheetam, I loved it when you framed it in your opening. The fact that manufacturing, particularly in the context of industries like steel, serious business. Right. People who are running shop floor operations, they have very low tolerance for something which is not proven, which cannot be trusted. Right now, AI, as it's permeated across all walks of life. Grannies are using it, kids are using it, everyone in between. Right, whether they realize or not. Yeah. Right. So AI is around us, and lives are getting transformed, whether in our personal lives, whether in our professional lives and business, whatnot. Right. You spoke about demos. Yes, of course. Right. You'll get very cool demos. You'll get to see a whole lot of stuff. What happens in a demo really happens in a controlled environment. With data that's been picked up for running that specific, let's call it a pilot. Right. And rules are relatively narrowly defined, and you're able to, what's the downside to it not working, right? Very little. Now, if you're able to successfully do that, it doesn't always automatically transplant itself well into a punishing industrial grade shop floor environment, right? That does not happen. The reason for that is AI in the context of, let's say, personal use or even enterprise sort of, let's call it the corporate side of the enterprise, right. In the offices, those use cases, a little bit of a glitch here and there, some inaccuracy, it's okay, it can be tolerated. It's not going to create patently dangerous situations, right? As may be the case in, say, a steel caster or any such high demand, application, right? So industrial AI, by design, has to be, it has to be explainable. You cannot really have a black box, which is what LLMs typically end up being. They'll put out a result which looks perfect, great, yeah. But you would struggle, the bot itself would struggle to explain. Right. It's getting better, but explainability isn't baked in, right? And explainability is absolutely needed. It's not only important for you to put the right results out, it is important for you to be able to also explain how those results were arrived at. Right. So that is very, very important. The other thing which is different about shop floor setting versus pilots or demos that you spoke about is we're talking about steel here, right? Very, intense environments, right? There's high temperature, humidity, background noise, et cetera, the signal to noise ratio, I'm using that term in a little broader sense, right? Very high, right? And you need your systems, I'm just going to broadly use that word, to be quite robust and rugged, right? Well proven. So explainability, consistency, right? And to be able to be designed for safety, these are paramount considerations.
I think you've given us some pointers that helps separate the chaff from the grain in many ways. But even before we come to models, Daisy, there is a backbone that an organization needs to build with connectivity and data. What are the absolute non-negotiables when it comes to this particular backbone? And I'm sure in your experience, you've seen a few red flags, right? The minute you have a look at a plant, you say, okay, they are not ready for AI scale. Tell us about both.
Yeah. I think, Sheetal, there's a very good understanding today that the network powered the internet, the network powered the cloud, the network will also power the AI revolution. I think connectivity is core to the AI conversation as well, right? There are some things that AI does. It puts loads on the network, it puts pressure on the network in ways in which we have not seen before. So you need very high throughput, you need extreme low latency, essentially you need lossless networks. Right. You know, networks work on the philosophy of they can drop 1 or 2 packets, but broadly the message from one end reaches the other end.
Right.
In AI, that necessity is even more. Most networks inside plants, and Dilip said on the carpeted area, it's great. It's not great. Right? Even on the carpeted side, networks are not built for what AI workloads need. That's problem number one. What do networks do? They connect everything. They connect everything on a plant floor to data centers to clouds. All of this is talking to each other all the time, generating data, sending data to each other, which is the context. That data then an enterprise has to organize, curate, to create the context that the AI models live and breathe by and then eventually will succeed. So I think on both these counts, both the ability to build infrastructure broadly, networks is a big part of it, and to create an enterprise or curate enterprise-wide data in a way that it provides the right context to AI models. Both of this is well understood problems that enterprises, manufacturers have to solve for. And it's not just at the factory end, it's broadly at the enterprise of the manufacturer as well. Earliest sign that an AI project will fail is infrastructure gaps. And, you know, it's become a favorite topic today called infrastructure fragility. Even execs are standing up on stage and talking about infrastructure fragility. And what they mean by is this. Years of technical debt has piled up into an environment where we've got to first fix the foundational layers before we can, before we can deploy AI models.
Right.
Because these foundational layers cannot be fixed by algorithms. They've got to be done the old-fashioned way, and then we can layer AI models, use cases, applications into that environment.
Right. Indra, up until now, we've really spoken from the point of view of the plant and to some extent other parts of the enterprise. And in that context, I want to anchor it in what we do here at Jindal Steel from the point of view of smart. What does smart really mean for Jindal Steel across plant, logistics, and functions?
It's a very relevant question that you asked, and I think the smart word to me, it means that how we are connecting the different processes.
Right.
How we are making the processes more intelligent. So if I have to give one example of Jindal Steel, so something we have developed called JAI. So JAI stands for Jindal AI. Now, JAI has been given a persona, and we are also working towards it to make it even to that extent of making it a virtual employee. But at present, what JAI is doing is like it is helping all the CXO offices to take a better decision.
Right.
I have to just put in a single line. And how it's doing it? Because we are using something called a RAG-based infrastructure. So it's retrieval augmented generation. The point which Dilip was talking about is that how can we make it repeatable? How can we make it more robust and resilient? Because the natural tendency of these LLMs is to hallucinate. Now, it's okay in your maybe private life or when you are just playing it with the LLMs, but then it's not absolutely okay when you are deploying those kind of models in the plant environment, right?
Right.
So that's where we have made it absolutely perfect. Maybe the perfect is a too strong word, but we are trying to make it 100% correct so that whenever I'm asking a question, it is able to give me the exact same answer, whether you are asking or I am asking it.
Right.
Because when it comes to, let's say, production data, when it comes to, let's say, sales data, you cannot be having a different numbers.
Correct.
Now, we have solved the part of what. What is the current sales number? But then the how part of it, the why part of it is very difficult to solve. And that's where actually the LLM-based reasoning models are coming into the place. And that's where the whole smart and connected philosophies are working, because an enterprise is not an isolation of operations, not an isolation or an island of, let's say, sales and marketing, right? So it has to be connected. When I'm talking about, let's say, sales and operations planning, it's between the demand and the supply, the matching of the demand versus the supply, right?
Right.
So, and by design, I think steel is a complex business, because the way the commodity prices are changing, the way the raw material prices are changing, and give these wars where your supply chain is getting disrupted. So it becomes even more difficult that how you are connecting these different islands of functions.
Right.
And that's where the smart, connected, as well as if you can put the AI, which is mimicking the best of the operators and best of your SMEs,
Right.
subject matter experts, it is going to really help. The thing is, like, when we have to connect all these processes, it is very easy to say, but very difficult to do, because to make something very simple for the user, you need to do a lot of complex integrations in the backend.
Right.
And that's where the smartness comes in our processes. And that is where I think AI is going to play a huge role.
Yeah.
So we have to be very sure that we can promise moon, but then if your basic building blocks are not there, then the things are not going to be scalable.
Yeah, just as what Daisy had mentioned earlier, the foundational blocks need to be in place. But Daisy, you know, when you connect plants end to end to logistics, I'm quite certain that new areas of potential risk and failure can crop up that leaders sometimes tend to ignore. What are some of these potential areas? And perhaps, you know, what's that one governance choice that can help prevent smart from becoming quickly or devolving into fragile?
When you know, this is a very normal place to extract value. Yeah? You do backward and forward integration in manufacturing supply chains. And so when you connect to supplier or partner systems, essentially there are 2 or 3 things that you have to keep in mind. One is that the interdependencies, people sometimes tend to overlook the interdependencies, which means a problem, which is a contained problem, not creating much havoc in that contained area, can quickly get exported to the whole operation and can create havoc in another part of the business. So interdependencies are a very important consideration. The second piece is when you connect your environment to any other third-party environment, you're extending trust to another environment that you cannot see and that you don't control. Now, it's not important you control it, but it's very important to have visibility across all your digital estate. And this digital estate is anything that connects to your digital estate or anything your digital estate connects to. So it includes the supplier and partner ecosystems as well. So one thing we definitely think you need to make sure that smart systems don't become fragile systems is this deep observability across your ecosystem. Doesn't matter. It's not about control, but it's definitely about governance, because what you cannot see, you cannot govern. What you cannot govern, you cannot protect. So visibility, if there's one thing we ask enterprises to focus on, or businesses broadly to focus on, is end-to-end visibility of your digital estate, including that estate that you don't own or control or operate.
Right. Yeah. So, you know, Dilip, it's evident by now. If people haven't got it, then I would be surprised. We should all get up and go. But smart isn't really about gadgets. It's more about decision flow. And when you look at that flow of decisions across, different functions, where do you see the maximum or fastest, no, I'm not going to say maximum, fastest impact of intelligence? Is it going to be on plants, logistics, energy, or quality?
Well, if you're not use the word fastest, I would have said all the above.
Okay.
Because really, this intelligence is giving you unprecedented powers to optimize across your end-to-end value chain. But coming back to how you defined it, one of the ways we define or we advise our clients when they're getting started in the journey to digital transformation is to because you always have to be very aware of the outcomes that you're trying to produce. And it's a good idea to begin from understanding, for manufacturers in particular, right? What are the reasons for unscheduled downtime? There always been downtime because you plan for it.
Right.
Unscheduled downtime, it can happen for a variety of reasons. It can happen very simply because there's a piece of equipment which is more prone to failure. It can also happen if you're not very well coordinated. So one part of the value chain is starving versus the other one which is overloaded, etc.
Right.
But beginning to understand what's the root cause of unscheduled downtime.
Right.
And manufacturers for years, decades have been doing very good analysis around the Pareto charts and what have you about what creates, such incidents. So that data is already available.
Yeah.
Some insights are there. Let's begin by understanding and then begin by identifying a few areas where you can tackle. You don't have to solve the world's hunger problem, but if you pick up one or two, it gives you enough credibility with the VP of Ops and such people for you to get the legitimacy to do the next pilot and then scale from there. Yeah.
Right. Speaking of pilots, Daisy, I want to come to you because something changes clearly when an AI pilot moves from that pilot stage into real operations on the floor where someone is relying on that AI. What changes and how can leaders and build in resilience into the design?
We talked about pilots and candidly, what is the cost of that failure, right? If every failure in a pilot is a learning moment, every failure in production is a business event.
Yeah.
So naturally, when you're making the shift from one to the other, you have to also, the mindset around which you plan for production also changes. I think a few things there. Dilip alluded to it briefly earlier. Pilots are built on highly curated, controlled environments and curated data sets. So whereas the live production environment is dealing with, Indra mentioned it also, right? Lots of real data flowing across many points in the digital estate. So that ability to handle that scale and that complexity, this is a big shift, and people building pilots have to think about the end state, scale and complexity. So that's one big shift. The other is a pilot, you can really look at the art of the possible. You're doing experiments to figure out the art of the possible. But in real production environments, you need constant validation, real-time monitoring, the ability to pull the plug on something if you think it's going wrong.
Right.
And last, this understanding that, again, in a pilot, you're pushing the edge of what this technology can do for the business.
Right.
But in production, you have to clearly acknowledge that you are augmenting human expertise. You are not replacing human judgment.
Right.
This is a big thing because in pilots, you don't have to bring in this judgment element and test for judgment.
Right.
But in production, you have to.
Yeah.
I think I talked about visibility earlier. AI is also bringing risks at a scale that we still don't know what risks it's bringing to the enterprise. So this ability to have visibility, this ability to build resilience and security into the fabric of the digital blueprint of the manufacturer, of the industrial environment, that's very, very important.
Right.
Because then you have the ability to detect. You have the ability to prevent, mitigate against any business outage.
Yeah.
But it's a big mindset shift between doing a pilot versus taking that same pilot into production.
So I'm sitting on the other side of the table, right? Because both of my colleagues are providing a lot of solutions and products to me. So I think for me, when I'm talking about or thinking about pilot, I need to be absolutely sure that what's the success criteria I'm putting. Because often what happens is like we go to the production floor, we started the pilot, and then after 2 months, we think about, okay, what were the success criteria? Is it the objectives are really met, or maybe we are at the 80%? It's about thinking it beforehand and then putting it down and aligning the stakeholders. Because there are a lot of stakeholders who are actually involved, whether it is a business users, whether it's a digital transformation team, whether it is like maybe the other stakeholders of planning guys. So once we come all together, okay, these are the 10 things which we want to achieve from the pilot, and then let's go ahead with that. I think that makes the job of even the solution providers also easy, because they also know that what's the North Star for me.
Yeah.
Otherwise, if they're talking only to the IT or digital team, maybe the business users have some other expectations out of that.
Right.
I can just add one more thing to it. I totally agree with what both of you said. I think the having success criteria defined, very, very important. But also when you're doing these pilots, you got to also have upfront in your mind somewhere an idea about, okay, there's proof of value, but there's also got to be some proof of scale. Because if you struggle with scaling it, and if it is not meant to be something which will go broadly across the enterprise, you got to figure out if it is the right pilot for you to be investing your energy in tech.
Correct.
And that's very difficult to do.
Yes.
Very difficult to do because the horizontal deployments and then the scale up from a pilot, that also needs a lot of foreboding.
Yeah.
Yeah, and the thing with AI is also that it's evolving at such speed.
Right.
In no technology was the end state always being revolving, changing on an almost daily basis.
Right.
What you could do with it yesterday, you can do much more with it today, and you will definitely do more with it tomorrow.
Right.
So in that situation, an end state that you defined yesterday also looks a bit outdated when you look at it today.
Yeah.
Right? So you're playing with a technology which is also like that. It's very exciting, but also very challenging at the same time.
Yeah. In fact, I was going to come to scale, right? And you all have mentioned it, Daisy. In your response, you spoke about a pilot, hitting roadblocks when it comes to scale. And yet that's the stuff, as you rightly pointed out, a business event. It's also the stuff of lurid headlines in newspapers, that kind of failure is catastrophic in environments like manufacturing, especially, right? So if you were to boil it down to 3 or 4 pointers on how organizations can avoid this break that happens when they attempt to scale an AI model.
So I think we ask people to look at it from 3 vectors. I think we've touched on it already, but I'll probably do a summary. Infrastructure gaps and constraints. This one is a deal breaker. Data, but more than just data, context that the data will provide, and security. I think because trust.
Right.
A lot of AI models, pilots are grounding to a halt because of the lack of trust in AI.
Right.
So we've got to build not just the resilience frameworks, but also the trust between the technology and the people.
Right.
These are 2 or 3 things. And maybe last, but most important, which we don't find now, is systems thinking. Because we have to figure out what is that interplay between the physical layer and the digital layer and digital at every layer.
Right.
And this kind of cross-domain thinking is not very common,
Right.
but it's absolutely important in the world of AI and for AI pilots to scale into production.
Yeah.
From practitioners' view, I think there are 2 elements. One we call a functional validation. The other is called what we call technical. Some people call it non-functional requirements validation.
I want to segue into robotics and automation and what that is really going to do for manufacturing, because I think everybody is gung-ho with that possibility. And Indra, I'm going to start with you. Robotics is clearly where AI, automation, and safety meet on the shop floor. What are those areas that you have seen robotics and automation deliver improve performance and also increase safety in? And what are the areas that still will require human judgment to be central?
The planning side, when we are doing the entire supply chain planning, it's a difficult problem to crack. And that's where I think is still, even if we are putting AI, we have to keep a human in loop so that the validation happens. But let's say when we are talking about an operation, whether it is a hot metal handling operations, whether it could be sampling collections, whether it is maybe assembling in an assembly line, that's where the automation, that's where the robotics is going to create a lot of productivity improvement. And generally in industrial perspective, if you see, we have a couple of different type of processes. So what we call continuous process or batch process, or a job-based processes, or let's say we have this assembly lines, right? So the different choices of technologies will be required to mitigate or to cater to those requirements of different type of processes. But the way the automation systems are actually improving, and even nowadays we are talking about humanoids, right? So the humanoids are advanced in such a way that in some of the critical stuff where we can put our people to safety risk, right? Those are the places we can actually replace humans by these kind of robots, right? And that is not only going to improve the productivity, but as well as going to improve the safety score of the organization.
When it comes to robotics and automation, and you look at, say, 3 to 5 year, I can't say 3 to 5 years, a very, very long window. Let's just say 5-year time frame and how it evolves. What areas do you think you're going to see the maximum change?
I think robots, it is very important for us to recognize the role that they're going to have to play. And that will have to happen eventually. We often describe it as the 3Ds.
Right.
So dull, dirty, dangerous, right? So all the dull, repetitive jobs where you have to really be doing the same operation over and over again. Dirty, of course, where either you have, sanitation,
Right.
The environmental constraints, etc. And then dangerous, of course, where you have confined spaces or, mining applications and so forth. So these areas very fit for robo-oriented use cases. And robos, as we know, they come in several form factors.
Right.
Those are the areas where we really need them to come in. You may ask why, right? So there's constant attrition going on, the shop floor, as in with every part of the enterprise, right? To bring in new age workforce to do these 3Ds, right? With the Gen Zs, very difficult to achieve,
Yeah.
right? And you cannot attract them. There are better work that they would eventually end up doing. So that's where, and then you need to scale up, right? Particularly in the context of India, manufacturing really has to scale,
Right.
So these are the jobs which are very fit use cases for any form factor of robots to come in, right? You asked me to talk about 5-year horizon,
yes.
right? What I can definitely tell you is, and I want to go back to what Daisy was talking about, which was around, the systems thinking,
Right.
the manner in which robots, be it, robo-dogs or humanoids or even drones, any form of robots, they, from being just plain autonomous equipments, getting integrated into a broader system of systems, right? How? And that's where in this whole systems-oriented thinking around solving and optimizing across the enterprise, that comes in, right? Perfect use cases are in warehouses, right? Where, you have to retrieve with high accuracy and high turnaround times, right? Around orders that you are already beginning to use AI to anticipate, right? So it requires you to be very, very tightly integrated across your business systems and then on the warehouse control systems or production systems, right? To orchestrate all across a system, right? And then you have these little AMRs that are shuttling in and out and just fetching just the right amount of stuff in the quickest turnaround time, right? And it's already being used, by the way. This is not science fiction. So I'm technically not necessarily answering on a 5-year time horizon yet, right? But what is certainly going to happen is that all of these things are going to get integrated into a much broader enterprise-wide system, solving and optimizing at a whole different level altogether, right?
Since we're doing crystal ball gazing,
Yeah. Yes.
if you look at AI, what it's doing is it's augmenting, right? So you're doing part of the task and the AI is doing part of the task. Artists are already using exoskeletons to create bodies of work. It may be in the factory too, like you're working side by side. 5 years on, it wouldn't be impossible to think you're working side by side with a humanoid or a robot. Because today robots work all by themselves.
Right.
They're programmed, they have a task, beginning to end, they do it. There's a human supervisor, but the human's not really handing them tools or taking tools from them or anything like that. 5 years on, I wouldn't be surprised the way in which physical AI is progressing, that it becomes an augmentation to a human worker, right? Or many robots or humanoids or AMRs are around. Like you have agents to a human today, 7 to 10 agents to a human today. You could have 7 to 10 humanoids,
Exoskeletons.
robots to a human And a human with, I saw some work with exoskeletons.
Wonderful.
Not my taste, but I mean, get some used to, but with 5 years on, it could very much be our world.
Yeah. While on the subject of robotics, Daisy, got to ask you, as robotics becomes more connected and software driven, there is this very real concern. And I think we brought it up earlier in the conversation of cyber risk. And this can be a huge impediment to innovation. Just when I'm starting to develop an innovation DNA, I'm going to, have this brakes put on my feet on account of cyber risk. So what is this whole concept of secure by design, and how does one build that out?
Yeah. I think the good news is we don't have to do anything different from what we are doing already, right? Most enterprises are on the zero trust journey. Sounds very harsh. Essentially says never trust anybody, inspect everything. And robos are no different.
Right.
Is anything, a robo is going to connect. It will connect to the factory, and via the factory, it will connect to the data center, the cloud, and everywhere else in the enterprise, to your partners and suppliers, which we talked about earlier.
Right.
So every time a robo connects, does it have the right to connect into that digital estate? And does it have the right to perform what it's doing?
Right.
So you're always monitoring anything that connects into the enterprise footprint. And the robo is no different. You're constantly monitoring it to see, A, should it be allowed to connect to what it's connecting? B, is it doing the work it's supposed to? Is it talking to the people and the assets it's supposed to in the enterprise? And zero trust is an architectural framework in security that we've rolled out. The world is following it. Enterprises are following it. Manufacturers are following it in plants. It's no different framework.
Right.
Protocols may be slightly different depending on the kind of robots that we use.
Yeah.
But there's already a framework in place. So that's the good news.
Yeah.
The bad news is there enough attention? Because a breach, you're right to call that attention to this point, because all of the breaches we've seen in recent time have come through not from the IT side of the house. It's mostly come from things.
Right.
That are connecting, increasingly connecting. For many years now, more things have connected than IT devices into the internet.
Right.
Robos are one more thing that
Right.
will connect, and connect at scale. If you look at the volumes, connecting at scale, particularly in the industrial world. So extending the zero trust framework to them and in integrating them also into the security blueprint of the organization is really the way forward. Fortunately, no new framework, no new architecture.
Yeah, so this is basically the OT security, I think
Yes.
we're talking about, and it's going to be a paramount importance.
No, without guardrails, see, it's not very difficult to establish that it will drift and it will hallucinate. These two things are very well established, right? It can also be, models can be jailbroke as well.
Yeah.
Already, they come with significant degrees of vulnerabilities inside them. We did an AI Readiness Index survey in India. Only about 7% of enterprises even have the capability to sniff this problem.
And with that, it is time for a quick set of questions. Let's start with you, Dilip. One myth that you've encountered with respect to AI and manufacturing. Myth.
We all know that AI feeds off data, right? So there's a tendency for us to just amass as much of data from wherever you can get it. So the quantity versus quality, sometimes we tend to veer off more in the direction of quantity. No, quality really, really is important.
All right.
Yeah.
Okay. You, Pedro?
The biggest myth is AI is intelligent because it has to be trained.
Yeah.
It has to be trained, and it has to be guzzling lot of data, lot of information. Then only it can become intelligent.
Daisy?
I think one myth clearly is that great AI can happen only in the cloud. It's cloud dependent. Particularly in industrial and manufacturing environments, I think the AI that matters and will matter eventually will happen at the edge.
Okay.
And not in the cloud.
Dilip, what's the one tech trend that has been overhyped, is completely overrated?
A little while ago, people were getting a little too carried away with Gen AI in manufacturing, right? It is very, very useful, right? Just not immediately. Manufacturing, actually, to Daisy's point, you don't have to have cloud-based intelligence. You don't always have to have the best, most cutting-edge models. You just need to have just enough intelligence in the context of that operation. So you don't have to get carried away, because manufacturing really requires reliability and consistency.
The dark factory that we are all hearing about, the lights out production, I think that is little overhyped. It's might be happening in the next 10 years, not immediately.
Okay.
And maybe blockchain. It's a has-been, bit of a has-been. When it arrived, it was supposed to solve for world hunger.
Yeah.
But minus contract management and things, use cases around
Yeah.
traceability.
Yeah.
That's a contract management, traceability. It has not found much use otherwise.
I'm going to ask you about robotics. What's that one area in the context of the changes, evolution of robotics? One area that's really going to, you think is going to really transform?
Permeation of this technology across all walks of life, not just in manufacturing. You are already talking about microbots and what game-changing impact they can produce in the context of, say, healthcare and surgeries and so forth, right? So they can intervene at a point where, in the context of warfare and so forth, you're already witnessing that.
Right.
So yeah, I mean, I think they're going to be altering the as a state
Right.
for us. If we can play our cards well, and if we can play a governance card well, society as human race, then I think it is going to be to our advantage.
And one final question for all of you, and this one's got to do with the one thing that will not change no matter what direction technology is going to take. And I want to leave our viewers with that kind of a note. What should leaders simply not outsource, irrespective of what advanced technology comes their way?
Technology is going to take away more and more of the how piece of it, right? It'll continue to rid us of doing things that are in the moment, and it's going to equip us with time and space to think about things which are human. I think that's how the teaming or collaboration will work for some period of time. There will be a tendency for people to also become a little bit lazy and allow the algos or the machines to take over things which are much more closer to humans, which cannot yet be transferred to the algos, which is the guardrails, the values, the judgment, right? That cannot be outsourced. That must not be. That's the cultural aspect of who you are as an individual, who you are as an organization, or as a family, maybe. You know,
Right.
we don't know where all these things will surface.
Right? Yeah.
I think one word answer is emotion.
Very well said.
Right.
Yeah. The human part cannot be outsourced. Rest, I think the way Dilip said, it will be slowly taken over. But then this is the part will be differentiator between a robot and a human.
And a human.
Yeah, and maybe it's quantifying that emotion in the business world. It's accountability.
Right.
And everything that makes accountability real,
Yeah.
whether that's judgment, emotional intelligence, the wisdom to ask the right questions, the courage to make the difficult decisions or calls,
Yeah.
everything that makes us human in the business world.
For our viewers, it's been, as you have witnessed, a delightful conversation. So we've clearly seen what AI can do. And we've also seen, more importantly, how enterprises are thinking, or it's revealing to us how enterprises are approaching this whole subject. This much is for clear, and our speakers have mentioned it across the conversation today. The future is going to belong to those enterprises that are going to very intelligently design and build systems, or rather put in intelligence into systems, people, and also, leadership. And it will also belong to all those enterprises who remember, as we just heard from Daisy, that accountability is that one thing that cannot be automated. It's been a brilliant conversation. I must thank you, Daisy, you, Dilip, and Indro, you as well, for bringing this room alive with your ideas and the optimism that you shared with us for the future. Thank you so much.
Thanks for having us.
Really enjoyed being here. To all of you.